All right, so how do you do these? How do we do these? All right, find a common denominator. I like how you said a common denominator. That implies that there's more than one. If you said the common denominator, that would mean, oh, there's only one. But a common denominator. So one way to do that would be to multiply all the denominators. That sounds like a crazy idea. But we're going to do it just so that you can learn why it's necessary or rather helpful to find the least common denominator. But if I was going to do that, right, so what I can say, 8 times 4 times 3, what that's going to do, that will automatically give me a number that will be able to divide all of these. Right? Yes, sir? Perhaps. Could be. So what I'm going to do first, before we do try Tristan's suggestion of 24, 32 times 3, that's 96. I don't want to have to deal with 96, but hey, this is what you would need to do if all of these were, slightly different numbers, or even if I went crazy and I made them variables. That would be a little silly, but we'll get there. So, if we're going to do this with 96, what would I have to multiply the 3 by? Well, look at what's missing. 8 and 4, right? 8 and 4, so 8 and 4 here. What would I have to multiply the 4 by? 3 and 8, or 8 and 3. Now notice I'm doing it on top and bottom because... Alright, we have to do the top and bottom because that equates to 1, and then the last one, 4 and 3. Okay? So we're getting some multiplication practice too here. 8 times 4 times 1, that's going to be what? 32 over 96 minus, okay, 8 times 3, that's going to be 24 over 96, and then plus, so 12 over 8 times 4 times 3. Again, that's 96. So this converts it to a form we can live with, and then we can operate with it. What do we get? How do we actually compute or calculate the answer here? Do we subtract the denominators and the numerators? No. What do we do, Tristan? Just the numerators. Yeah, we're going to leave the denominators the same. All that business up here of converting it to a common denominator is what allows us to then do this to the numerator. So 32, wait, do I do addition or subtraction first? It doesn't matter in this case because they're both part of the section right there with addition and subtraction. We go left to right. So we're going to subtract first. 32 minus 24, that's 12. I'm sorry, that's 8. 8 plus 12, 20 over 96. Now the fact that we can reduce this probably means we didn't find the LCD, as some of you are already hinting at. But 20 over 96, what can we divide by to reduce those? 4. Sure, 4. 20 divided by 4, 96 divided by 4. We're going to get 5 over 24. Oh, there's that number. All right, so that was one way to do a problem, and I'm going to elaborate on that in a second. But let's do it with the LCD. That I'm still curious, how do you guys get to the 24? Right, if we have 1/3 minus 1/4 plus 1/8, how do you get 24? Like, what do you have to do or think to figure out that it is 24?
3 times 8.
3 times 8? What does that have to do with the 4?
Just 4 goes into 8.
4 goes into 8. So anything that is divisible by 8 is also divisible by 4. Okay, you think about the factors that are kind of understood or built in. I'm going to give you another tactic. I want you to choose the largest denominator, which is 8, and then we're simply going to write the multiples of it. 8, what's next? 16, all right, 16. 24. We can keep going. We'll just do like a couple more. We could go all the way to 96. That would seem kind of silly. But this is just one way to think about it. 8 doesn't divide 3. 16 doesn't divide 3. 24 divides all of them. So 24 is definitely going to be the LCD. So some of you can look at 1/3 and think, oh, that's what out of 24? Okay, so we can't do that. Okay. All right. So we're going to multiply by 8. So I've got 8 out of 24. And then over here with the 1/4. What's 1/4 of 24?
6.
Is 6. All right, times 6, times 6. And then what's 1/8 of 24? We'll multiply by 3. So plus 3 out of 24. So we get an answer. I need one more color. Not to worry. 8 minus 6 is 2. Plus 3.
15.
Okay, now you're just being silly. So it's 5 over 24 like we found out. We just didn't have to reduce at the end. So think about this just briefly for a minute. Quentin said find a common denominator, which implied, hey, there's more than one way to do this. But if we say I want to find the smallest, I use the because there's only one least common multiple or least common denominator. Questions? All right, so we got a couple things in there. We reviewed least common denominator, adding and subtracting fractions, as well as order of operations. Do you see how math just keeps building? It's different than, it's not really different than history. Human history keeps, anyway, all right. But you don't have to know, I'm just going to run myself into a hole here. So I'm going to give you one last abstract. You know what? We're not going to do that. We're not ready for that. We don't need to do that. Let me ask if there were questions on the homework that were bothersome to you. Questions in lesson 30 or 31 that gave you trouble before we dive into 32. Which one? Oh, no, that was just a yawn. Okay. Adding and subtracting fractions. And then order of operations. Remember, we did those kind of backwards on Thursday. Any questions on the homework that you were like, this bothers me? Your mom or dad or brother or sister had to help you with?
Yeah, but I already know how to do it now.
Sweet, okay. Okay. All right, so lesson 32. Here we go. So we're gonna write a couple of definitions here: variable and evaluate. Okay. Hey, there it's focused. Okay, so guys, give me a definition for variable. I mean, have you worked with variables before?
No.
You have in this class.
Well, it takes place in a number.
Okay. All right. So a lot of people start complaining. I liked math until they brought in the alphabet. But the reason we need these I'm going to put a little apostrophe, letters, because, we can have expressions that have more than one. Letters that represent an unknown quantity. Okay? And I use the word quantity to kind of give Autumn's definition a little bit more breadth. Okay? Oops. Letters that represent an unknown quantity. Because if we knew the quantity, we wouldn't use a letter. We'd use the number. Right? Letters that represent an unknown quantity. Why is that valuable? Well, let's think about the word and the roots here first. Vary means to what? To differ. To be able to change. So it's able to vary. Hence the word variable. Its value is able to vary. So, if it's an unknown quantity, what we can do is represent relationships without knowing the specific values. Okay? Now, think about that just for a moment with respect to Tickets. Tickets to a Grasshoppers game. Okay? I'm going to write an expression. 10T. 10 times T. Why did I do that? Why not? Which is the same thing as just 10T. Okay? 10T. And I tell you that this means that the tickets cost $10 each. Okay? The tickets cost $10 each. What does 10T mean, do you think?
$100.
10 times whatever T equals.
10 times tickets.
Okay, so you're getting closer. You're all kind of getting closer, honing into that answer.
Each ticket is $10.
Well, it said that already. Each ticket is $10, but what does 10T mean? Fisher, what'd you say?
10 times whatever T equals.
How many tickets? How many tickets are going?
That's what T is.
Yeah.
So you need
But what is 10T, since each ticket is $10
Times T. So 10 times 10.
the amount of money you're going to spend.
on
Tickets.
however many tickets you buy? There it is.
Pretzel.
So that's the so this is the total cost that you would pay based on how many tickets you get. So wait, I didn't tell you how many tickets I was getting. So Finley, you were assuming that I was going to do $10 or 10 tickets.
Yeah.
And at $10 each, 10 times 10, that's 100. But I left it T.
What if you only buy one ticket?
Then the cost would be,
$10.
but if I bought 3 tickets,
30.
but if I buy T tickets, the cost is
T.
10T. 10T. That's kind of a lot to say there. 10T represents the cost of however many tickets you
Wait.
buy, since each one is $10.
So you didn't go to buy tickets. You say, "I'll take T tickets, please."
Not exactly, no. But if you're the person who's coding in
Doesn't that still mean
the register,
10 times whatever
or
the T equals?
what do you mean?
So why don't you just
After
say
we figure out what the T is,
All right, you got to think about this you guys are thinking like way too practical, and I get it. That seems like that's what makes sense to us, right? We want to be able to use this, but I'm on the theoretical level here for a second, okay? So you guys ever done the the little kiosk in front of the movie theater where you go order tickets on the screen? Right? Do you have to punch in how many you want?
Yes.
Yeah, but
So before you do that, the computer has already calculated your price. You know how? A formula like that, 10T. It simply requires a user input. Okay? It will ask you a question. How many tickets do you want? You type a number, and what it's going to do is assign that variable the number you just picked. That's how it knows how much to charge you. But if somebody didn't put in this expression 10 times whatever the user types in, it won't know what the cost is.
So it multiplies the price by how many.
How many? What number you type in. Exactly. That's exactly what it does.
wait.
Why doesn't it just wait until you put in how many tickets?
It doesn't compute it until you put an input in.
Wait.
It has a formula built in. Now, here, just hang on a second, I'll get to your question. If somebody didn't do this on the front end and say, okay, whenever the person types a number, you multiply it by 10. You see, computer language is a little bit different. You can't just tell it what to do like you would tell your 5-year-old brother. You've got to give it specific instructions.
my dad said computers are the most literal thing ever invented.
That's true. You've got to be very clear with your instructions, okay? Sir.
What if like tickets for younger kids cost less?
Well, that complicates things a little bit, right? We're going to the matinee, so all the tickets are the same.
What if you buy popcorn?
That's a different point of sale. Okay? That's a different. You go. Now look. I had to do a program when I took a coding class back in 2016. I had to do a program that was like checking out of a Mexican restaurant, and burritos cost something, and tacos cost something, and salads cost something, and then it gets really
Is a
interesting. 'Cause
Mexican restaurant in the movie theater?
you totally missed the introduction to this story. You missed the introduction to this story. All right. So, anyways, you have to have almost a formula set up. A lot of people will just say math is just formulas. It's not. But what I'm talking about now can be kind of thought of as that. 10T is essentially the formula that tells what's the total cost for however many tickets you get. Okay? So all the computer would need is your number, and then it would spit out the value times 10. because it's set up as a variable because T will be different from Nathaniel if he's going to take 4 people and Luke who's going to take 17. It's set up as a variable. Why? Because T can change value depending on the person. Yeah.
Well, why don't you charge tax?
Okay. Yes. But
Wait,
you
what
can
if-
do that after.
What if you get in and then, what if I get in with my 17 people and then 16 of them quit? And they say, I don't want to watch the movie.
Quit the movie.
All right, you've already bought the tickets. There's no refunds. Anyways, why do we do this to ourselves? We do this because we want to have a formula that can vary. It can do different things depending on an input. Okay, so a variable, again, represents a quantity we don't always know the value of at the time. And then when we find out more information later, it's able to calculate depending on what the input was. This is eventually going to lead us to an equation, or what I like to call, and you guys will do a lot more of next year, functions. A function is basically a relationship between 2 variables. You guys want to see what it looks like?
Yes. Wow.
A relationship between tickets and cost. What's the difference? All I did was put an equal sign. Okay, so this is foundational. We want to understand a variable is simply a letter that represents a quantity that I don't know.
Wait, so you can be charged $C? Like the ticket thing say.
It's not. It's a look. No. Listen. Look. It's a variable which represents a quantity you don't know yet, and the reason I'm using yet implies you're going to know when some other things take place. When you find out how many tickets, you'll find out what the cost is. Do you see that?
What I didn't know for money.
Now you're just playing. All right, so evaluate. What word do you guys see in evaluate?
If I don't know the cost of the tickets, then I might not bring enough money.
All right, you're still stuck on that. Look, you're close, Ella.
I'm just trying to figure out how you decide
Value.
value.
Balloon?
Wow.
Value, yes. So evaluate means to find the value of an expression. Woo, that is really terrible handwriting. Find the value of an expression by substituting. That's really difficult to spell while you're talking. For the variable. And then another, potentially, there could be 2 variables or more. So, find the value of an expression. Wow, that's terrible. By substituting for the variables. You guys actually already did that. When I said, if you buy 3 tickets, what's the cost? According to that formula?
$30.
$30. All right, now look. We can do this. So let's say I want to do 10t when t equals 3. So what we do, we'd say 10 times. We're going to replace or substitute t for 3, and we'll get 30. That's all evaluate means, is to plug in a number for the variable that you were given. Okay? So let's say we had 10t when t equals 31.7. And it's no longer tickets. That makes really no sense. If I had, say, 31.7 tickets, you can't have 0.7 tickets. Okay.
Because it's the child cost.
All right,
A
so
little bit less.
what do you do?
So it is 0.7.
10. I'm going to write it a little different. Many times students mess up when there's negatives involved, so we don't want to make those mistakes. I want to put this in parentheses, 31.7. It doesn't mean that I do anything different. It still means that I want to multiply 10 times the number inside. And what do you do when you multiply a number by 10 in terms of the decimal?
Just add a
Well, I don't want to add a 0 in this case until I'm sure that I've moved the decimal. So there's 1 0, so I'm going to move the decimal exactly 1 time. So I'll get 317. They're all pretty easy. Now that I'm not talking in a foreign language, at least that's what it seems like. So let's change the variables up a little bit. Let's say we have AB minus C when, now how many variables do I have here? 3. So if you're going to truly evaluate this, I'm going to have to give you the value of each of those variables. So we'll say A equals 2, B equals negative 1/2, and C equals, how about 4? This could get ugly, especially with the amount of room I left us. So, how do we do that? Well, again, I have 3 variables, but to evaluate means to find the value of this by plugging in or substituting. Which word do you guys like better? Substitute or plug in? Substitute. Okay, cool. AB. What does that mean to do? Yeah. So I'm going to write them. 2 times negative 1/2. If you want to stick the negative 1/2 in parentheses, be my guest. I'll do that. 2 times negative 1/2, and then minus C is 4. So all I'm doing, I'm evaluating by plugging in the variable's value and computing. Okay, you could say solve it, but that's a little too general. Evaluate has a very specific meaning. It means find the total value when you know the variables. So what is 2 times negative 1/2? Negative 1. So we do the multiplication first because of order of operations. Yep. And then we'll subtract 4.
Negative 5.
Oh, we're going to have some fun then. You guys didn't like my pirates and ninjas story, but guess what? If all the pirates are positives, all the negatives are ninjas. I have 2 negatives. There's 1 ninja and 4 ninjas makes
Negative 5.
5 ninjas.
Negative 5. That's what I said.
You said that secondarily. You said negative 3 first.
Yeah, but then I realized why negative 3 makes no sense.
All right, so let's talk a little bit about those. If that's giving you trouble, okay? If that's going to give you trouble, we gotta nip that in the bud, whatever that means. I never really understood that. Negative 1 minus 4, okay? You guys have a negative opinion of these? All right, anyways. So, I'm starting at negative 1, and it says take away 4. So, one thing to do is to think about the opposite, right? If you think, well, I know what plus 4 would be. Plus, when I add a value, it means I move what direction on the number line? Huh? To the right. You go up. So, plus 4 would be over here at 3. But if it said minus 4, that means I'm going to go that way. Yeah, that's what I'm doing.
But the 4 was positive.
The 4 is positive. So I want you to think about something. If you lose something positive, you become more negative.
Yeah. If you minus and negative, you cancel each other out, so that's a plus.
Maybe we should look at that for a
So
second.
negative 1
But
plus
what if some
negative
of the
5.
pirates want to join the ninjas?
They don't make this harder than it is.
It's the same thing as negative 5 plus negative 4.
All right. So, hang on, Luke. I'm gonna elaborate on that. Negative 1 minus 4 can be written as negative 1 plus negative 4. So you have 2 negatives. You can think about negatives as debts. You owe one friend $1. You owe another friend $4. You owe a total debt of $5. And the concept of debt means a negative value. Okay? So, negative 1. And what we're going to do, that's supposed to be, so here's 0. I've got that amount, and then I've also got that amount. So 1, 2, 3, that's terrible. That's not really going to make sense to anybody. For a total of negative 5. Oh, it's been a long time since I've done this. So, that looks like negative 1/5. Why did I do that? Alright. I don't like the way this looks. I need a better number line. We need to do some integer problems like this? Is that? No. We need to feel good about this. This is a foundational skill.
I feel good about it.
Well, I feel good with what you just said about how that debt.
Well, that's actually why the general population adopted negative numbers, because negative numbers weren't really a real thing until we had the concept of debt, and we were able to say, you owe me this amount of money. We need to be able to express it.
But are they really a real thing?
Are they a real thing?
Well, not
So,
really.
if you think about it this way, negative cookies, negative sugar. Were your sugar cookies negative the other day?
Yes, very much.
Um,
I had -5.
physically, Autumn, no, and that was the hard part for people. It's like, I can't see a negative number, right? You don't teach somebody to count things that aren't there.
1, 2.
So
1, -2,
think about it this way, though.
-4.
I just realized that when I said that, counting things that aren't there, right?
-2.
If you made
-2. I counted a -2.
a half a dozen muffins. Oh, you really want to see my muffins?
Those are muffins that are on fire.
Hey, doesn't that mean good? Isn't that what kids say? Those things are fire. Like, does that mean they're good or?
They're lit.
Oh, that's older, isn't it?
I think they exploded.
All right. So I made 6 muffins.
Gunpowder.
I made 6 muffins. What happened?
Where's the other ones? They're right there.
All right. I'm too short.
That's because I went there and ate them.
So what we had to do was be able to illustrate how many less are there. And I know you're thinking, why do you need a negative number to do that? It's just 2 below. But think about representing that value, right? Autumn shows up to the bake sale and she's too short.
Uh-oh.
In order for us to get the right total,
Finley and
right, we'd be
Nathaniel
2 below our quota. You guys know what I mean by quota? That's how many we expected. Luke's going to have to bring in 2 additional to balance out. So a plus 2.
Because then poor Nathaniel and Finley won't get a muffin.
Anyways, what I'm trying to get at here is that negatives, no, it's difficult to see them physically, but they illustrate being below 0. How many below the 0 line we are?
Can't you just minus 2
From what?
from 6?
So
The only thing is 60.
if you're thinking about it like a quota, like an expected value, to illustrate that you're 2 below what you expected. I know you're thinking, just subtract 2, right? But what if you don't know what the value is?
Then you use a variable.
Uh-huh. And what if the variable's 0?
Then the answer is
0 minus 2,
Yeah, you just write that.
which means
-5.
negative 2. Negative 2.
-2.
Does 6
That means that
minus
numbers
2
are now
equal
joining
the
the
same as
pirates?
6 times
I know.
negative 2?
So, let's think about something. Here's what I have.
Means an
I have 4. And I was expected, let's say what I have, and we're going to subtract what I was expected, which is 6. So that means I'm how many? So by saying, hey, that's negative 2, what is implied there is that I'm 2 below the expectation. Okay, I'm 2 below the expectation. And this is, positives and negatives are used all the time in things like manufacturing. Right? Golf balls, for example, have to be manufactured to a very, very tight tolerance. A specific, detailed size.
You have to write number of holes.
I don't know how many dimples there are. There's probably something to do with that. I'm talking about more about the diameter, okay?
One had like 50 dimples.
So, it's probably more than that. Anyways, I don't think I have time to really talk about that a whole lot more. But the rules are, so let's say we had -4 plus 5. Anytime you add, we're going to move to the right on the number line. Anytime you subtract, we're going to move to the left. But the part that I think some kids get hung up on is, what if you're adding and subtracting a negative number? So what we want to be able to do is write it with a single symbol. The single symbol. So simply going to the right, -4. I'm going to go to the right 5. That puts me at 1. Whoop, 1. Okay, that's a 1. It's a bad one, but it's a 1. And then -4, and I move left 5. That puts me at -9. But at the foundational level, right, adding means go to the right, subtracting means go to the left. So when we get to a problem that has a double negative, like somebody was talking about, I feel like you probably discussed that in ELA, right? Language arts. What does it mean when you use a double negative?
Cancel each other out.
All right, that is true, but linguistically, does that mean that's
Turns into a
The
positive.
ninjas can be pirates.
No,
traitors?
they just kill each other.
So,
No, the ninjas.
Yeah, but pirates is the same letter as positives, and ninjas the same letter, right?
all right. So, listen, guys. So let's say we had 5 minus -3. A lot of times it won't be written that way. Sometimes it'll be written like this.
Then just make the pluses sign.
So, it equals the same thing as 5 minus negative. You put the dashes there, it can kind of get confusing, so that's why I did the smaller one a little bit higher. But what I used to say is that the two negatives get together and have a positive party, because it takes, that one, that, and that one, that.
They join together.
So, think about it another way. Think about it,
They get welded
if you
together.
get rid of something that's bringing you down,
And you get happy.
your mood goes up. Wait a minute.
Coming back in.
If you get rid of negative influences,
Wait, so
things
that
become more positive.
So that means if we burn on
So get rid of
we
Finley?
get happier.
Do what?
We gotta get rid of Finley. He's a negative influence.
No.
So, that doesn't really jive with what I said, because earlier I said, hey, when you subtract, you go to the left. But what I want to make sure you see is that you always want to try and write it with a single symbol. And then adding means go to the right on the number line. Okay? So if we had a similar problem, 5 plus -3, if you introduce something negative into your life, you're going to lose. Oh, again, here we go. You want to write it as a single symbol. So what does it mean to add -3? That is the same thing as 5 minus 3, which minus means go to the left. I'm going to go to the left. I'm going to get 2. Okay? So write it with a single symbol as often as you can, if you have trouble with that. Most of the time, though, just doing this enough, like in the Delta Math for this week, will give you the practice and the foundation that you need. So the last part that I want to talk about for Lesson 32, we've already done quite a bit of it, is more evaluation. So evaluate each expression, and I'm going to give you 3 new variables, okay? When x equals 2, y equals 3, and z equals 1/4. Okay, so we got a couple that I want you to do. X, y divided by z, and x over y,
Z times Z
plus x over
Z
z.
times Z.
No, I'm not going to do that. So those two, work on those for a couple minutes. Yeah.
X times Y divided by Z.
I don't even know what we're doing right now.
So we got lots going on here. We got evaluation. We got to think about order of operations. We got to think about how do you add fractions.
But I don't know. I don't know.
It's just numbers.
I don't know what the common change y and z to equal. Like,
You don't before you plug in your numbers. You plug in your numbers first.
Is there any negative?
yeah, this makes no sense.
It makes plenty of sense.
Can I add new variables?
No.
Dang it.
Why did you want to do that?
So that I can do like some other variable times y. No, actually, it doesn't do that. It does.
Okay. Okay. So plug in your numbers first to evaluate.
Oh, you gave us the number.
I gave you the yeah. That would make things really difficult if I didn't. So 2 times 3 divided by 1/4. Okay? So let's do times 3. We talked about that briefly last week. When you have several things going on in the numerator, before you can divide, you have to find out the simplified numerator. 2 times 3 is 6. And so we'd have 6 divided by 1/4, which means 6 times,
0.25.
no, 6 times, I changed it from divide to multiply, so I want to change 1/4 to 4 over 1. So that's 24. I would have been confused too. Alright, x over y. X over y. So x is 2. So I've got 2 over y, which is 3. Okay, 2/3 plus, okay, this one, x is still 2. And then z is 1/4. So before I can add these, we talked about Thursday, got to get a common denominator. Or would you rather simplify 2 over 1/4 first? You do have a choice.
I would rather simplify.
Yeah. Well, what?
It's going to be kind of difficult to get. It won't be difficult. We can do it.
It's 24.
It's 24?
24 over 3.
What if I told you it was 3?
No, the denominator is 3, but the one above is 24.
Oh, I see. You're quick. How'd you get that?
Because 2 times 5 is 24.
Okay, so you saw that there were 12 fourths in 3.
Yeah, because
Okay.
4 times 3 is 12.
Okay, all right. I'm making sure everybody's on that same wavelength here. So if you don't like that, right, which Luke is perfectly justified, and he's probably going to get it a little bit quicker if he does it that way. What we can do is think, well, how many times does a quarter go into 2? How many quarters are there in $2?
I have no idea.
8. Right, you can say 2 times 4 over 1. Yep, that's 8. So what we'd be trying to add is 2/3 plus 8.
8 over what?
Well, what do we do when it's not a fraction?
Over 1.
Stick a 1 under it.
Oh,
And then you think, well, now it's going to be really easy to turn that into a 3. All we got to do is multiply by.
1, 3, 5, 6, 7, 9. 3.
You were doing so good. 3. So I've got 2/3 plus 24/3 What's 2/3 plus 24/3? 26/3, or the mixed number, Autumn? 8 and 2/3.
We didn't really have to do all that.
All right.
Could we just add the 8 to the
8 plus 2/3 is 8 and 2/3. So you are right. It depends on what we're asked to do. Do we want to express the number as an improper fraction? Then you could, but then, even then you could just go from there to the improper fraction. Okay. All right. I didn't know that's how it would work out when I wrote it, but that's what it did. So the last thing, and we'll just kind of,
I just got 26 thirds.
huh?
I got 26.
That's right. Also,
You have to make it into.
You have to simplify.
well, look. I didn't say have to
That's too
anything.
much work.
Delta Math will ask you to write your answer in a specific format. So sometimes it'll say, give me an improper fraction. Sometimes it'll say, give me a mixed number.
Yeah.
Okay? Sometimes it gives you the freedom to do that.
And
So,
improper fraction works because you didn't tell me.
all right, the last thing here, a brief introduction for lesson 33, and then we'll adjourn here. 16 square inches equals how many square feet? So the difference here, we already talked about unit conversions. We know that there's 12 inches in 1 foot. So would you just think, oh, it's like 1 1/3? Or does it work that way?
Wait, why'd you use a question mark instead of a variable? I thought we just did a bunch of variable stuff. It's not a letter.
I don't know. I just wrote it that way.
You can make
We could make.
anything could be a variable. You can make this shape a variable.
All right. So we're going to use letters, but for this one, I just wrote a question mark just to illustrate. Hey, this is what I'm looking for. What we have to do here. 16 square inches equals how many square feet? You got to think, how did I get the 16? How do you get squared inches? You do inches times inches, right?
Inches times inches equals inches.
It equals inches squared.
Inches squared.
Yeah.
I got that right the first time.
Whew! Let's save this one for next time. I can't rush through this one. All right, so see if you guys can figure that out. Figure that one out by looking in the book at lesson 33. I don't want to rush through it because it's time to go anyway. So work on that, just that one. You don't have to do the lesson 33 homework yet. Just this problem. Okay, I want you to look in the book, see if you can figure that out. So all you've got between now and Thursday is lesson 32 homework, and you should start the delta math so that you don't email me on Friday and say, what do I do? You did it, what, 9? Wow. Did you use your phone? You did it on a computer? Wow.
Yeah, she sent me a picture.
I think I'm 86% done.
For next week? Or this week? Oh.
Yeah, she did it in 9.3 seconds. She did what? She did the, this thing in 9.3 seconds. I did it in
That's really fast.
Oh, I didn't.